Om Namah Shivaya. Hi friends, how are you? In this video we are going to learn about dead space. The tidal volume. The tidal volume occupies the respiratory tract that consists of conducting and respiratory airways. The tidal volume occupies the respiratory tract that consists of conducting and respiratory airways. The fraction of tidal volume that occupies the conducting airways does not take part in gas exchange. The fraction of tidal volume that occupies the conducting airways does not take part in gas exchange. For each 500 ml of air inhaled, about 150 ml remain in the conducting airways. For each 500 ml of air inhaled, which is tidal volume, about 150 ml remain in the conducting airways, which is not used in gas exchange. Okay. This volume wasted air is known as dead space volume. This volume of wasted air is known as dead space volume. Thus, dead space is defined as the space within the airways that does not allow gas exchange with pulmonary capillary blood to occur. Thus, dead space is defined as space within the airways that does not allow gas exchange with a pulmonary capillary blood to occur. Since the dead space is due to anatomy of the airways, often it is referred to as anatomical dead space. Thus, dead space is defined as space within the airways that does not allow gas exchange with pulmonary capillary blood to occur. Since the dead space is used to anatomy of the airways, often it is referred to as anatomical dead space. Due to the anatomical dead space, out of the 500 ml of the tidal inspiration, 350 ml of air enters the alveoli. Thus, the normal dead space volume is 150 ml. The ratio of dead space volume to tidal volume in normal health is 25 to 30%. Thus, normally 30% of the minute ventilation does not participate in gas exchange. The ratio of dead space volume to tidal volume in normal health is 25 to 30%. Thus, normally 30% of the minute ventilation does not participate in gas exchange. Next, physiological dead space. Okay, physiological dead space. Some amount of inspired air in the alveoli does not participate in gas exchange. Some amount of inspired air in the alveoli. See, some amount of inspired air in the alveoli does not participate in gas exchange. This happens as various alveoli due to various reasons have little or no blood supply. Okay. Therefore, air in this alveoli also becomes a part of the wasted air. The volume of air in this alveoli is referred to as alveolar dead space. The volume of air in this alveoli is referred to as alveolar dead space. The sum of the anatomical dead space and alveolar dead space is physiological dead space. Okay. The sum of the anatomical dead space and alveolar dead space is physiological dead space. Physiological dead space is equal to anatomical dead space plus alveolar dead space. Alveolar dead space is negligible in normal individuals. Therefore, in normal individuals, anatomical dead space is almost equal with the physiological dead space. Alveolar dead space is negligible in normal individuals. Therefore, in normal healthy individuals, anatomical dead space is almost equal with the physiological dead space. However, in various lung diseases, alveolar dead space volume become high, in which the physiological dead space is more than the anatomical dead space. Okay. In various lung diseases, alveolar dead space become high, in which the physiological dead space is more than the anatomical dead space. Okay. Okay guys, this is about the dead space. Okay. If you like this video, like, share and subscribe. Thank you.